If the probability of A is 0.6, the probability of A given B is 0.6125, the probability of not being B is 0.2. Calculate what's the probability of A and B and what's the probability B given A. So just make sure that you understand that this, let me just change, that this and this is not the same thing. Okay, A given B is not the same as B given A. We're going to do this as we would do with a algebraic problem. We'll have to manipulate equations and see what we have. Now we're going to write down what I have. I have PA, which is 0.6. I'm going to have PA given B is 0.6125. I have the probability of not B, that is 0.2. I'm also going to write down my two equations that I know. I'm going to write that in a different color. I'm going to say the probability of A given B equals the probability of A and B divided by the probability of B. So A given B means it needs to be, if we say A given B, it is A and B divided by the probability of B. So those two need to be the same. And then we also have the probability of A and B equals my multiplication probability is PA multiplied by the probability of B given A. Now if I have to calculate in the first question the probability of A and B, let's see where I can find that. That probability of A and B is over there and it's also over there. So I can calculate one of those. What information do I have? They give me the probability of A and B. I don't have the probability of B. I do have the probability of A. I don't have the probability of B and A. I also see that this question that they've given me here is what I have to calculate there. So it will be very hard to use this formula, the second one, very hard to use this to find the probability of A and B. So let's see if we can calculate the probability of getting B. They gave me the probability of not B. So that will be pretty easy then to calculate what's the probability of B. So what I'm going to do is I'm going to say the probability of B using 1 minus the probability of not B. In other words, 1 take away 0.2 and that gives us 0.8. So now I have this value and I can just find the probability of A and B. Again, you can decide if you want to substitute values before or after. So I'm going to multiply. I'm going to say the probability of A given B equals the probability of A and B divided by the probability of B. I'm going to multiply both sides with the probability of B to make that the subject. Okay, so that's going to cancel. So I'm going to have the probability of A and B equals the probability of B multiplied by the probability of A given B. So that gives us probability of B is 0.8 multiplied by the probability of A and B, which we have as 0.6125, and that will give me an answer of 0.49. Now I have this value, I have this value, so I'll be able to calculate what's the probability of B given A. So I'm going to use this formula now to get the second part, which is that one. So I can say the probability of B given A, and what I'm going to do is I'm going to divide both sides with B over A, or the probability of A. So it's going to be probability of A and B divided by the probability of A. Probability of A and B, we just calculated was 0.49, divided by the probability of getting A, which they gave us at the start, is 0.6, and that works out to some value. I'll quickly check on my calculator. Clear 0.49 divided by 0.6, and that gives us 0.82. Right, so that will be my final answer.